Hi everyone. My name's Tom. I don't think I know many of you. I'm a data strategy advisor and machine learning engineer. And I have no affiliation with the Swift for TensorFlow team. In fact, I've just come back from learning about it at a course. So I don't know if any of you know about Fast AI, but they're an online deep learning school. And they do an in-person version of their course. And recently they taught, along with Chris Latner, who some of you might know is one of the inventors of Swift, Swift for TensorFlow. And so tonight I'm going to talk about it. It's just going to be an overview. I'm not trying to do a tutorial. So we'll see how we go. I'll try and do the what and do the how and do the why and just talk about it. Feel free, happy to keep it extremely casual. So if there's anything burning questions, just shoot your hand up and let me know. Oh yeah, before I get totally stuck in, has anyone heard of this before? Hands up. Okay, almost most. How many of you have coded in Swift before? Don't be embarrassed and not put up your hand. I won't judge. I am not, to be explicitly clear, I'm not an iOS engineer at all. This is not about iOS. And I have never, I've never made an app of any kind. So feel free to critique any code you see on screen. I would actually like that. Has anyone done any machine learning before? Okay, all right, pretty good. Has anyone used TensorFlow before, specifically? Almost the same people that have done machine learning? Okay, great. All right, so what is it? Basically, Swift for TensorFlow, as you might be able to guess from the name, is a framework for doing deep learning in Swift. I'll break that down a little bit. Swift, you all know what Swift is. I don't have to go into too much detail here. There are some Swift-specific features that make it particularly interesting for this, but we'll talk about that as we go. TensorFlow, for those of you who haven't used it, I presume most people have at least heard of it. If you don't quite know what it is, that's totally understandable. It's actually a pretty complex beast. Effectively, you can think of it as a runtime and set of language bindings to do, particularly engineered towards doing very high scale compute on neural networks, i.e. giant matrices, right? And sort of particularly to take advantage of different accelerator architectures like GPUs and TPUs. And machine learning, because we're going to be talking about it, I have to make sure that everyone knows what we're talking about. All I want you to think of it as is it's just a computer program, and it sort of wrote some of its own rules, right? Like it's just a computer program where you didn't have to go through and write all the if statements. It learnt some of them itself. You don't have to think about it too hard beyond that. Deep learning in particular is just a currently trendy way of doing that. We'll talk about that more later on. So that's definitions out of the way. Concretely, what is Swift for TensorFlow? It's a few different things in the package. This is the official Swift GitHub page, and you'll note there is a TensorFlow branch. So Swift for TensorFlow is actually a fork of Swift, and they are feeding features back into Swift main through the Swift community process. I think a couple of features have already made it in. And it's also a few other things. There's a Swift package called TensorFlow, which actually does the bindings to the TensorFlow runtime. And there's some other packages that help you run it in Jupyter Notebook and things like that. How this manifests is if you want to crack it open and have a go, then you can download an Xcode toolchain and write an Xcode project that uses it. Or what most of the work is being done in is nothing to do with Xcode at all. It's taking advantage of Swift as a standalone general purpose language, and you can download a kind of dedicated runtime of Swift to run on Ubuntu. Any questions so far? Yes. Yeah?
Is it a special Swift or just Swift with some additional libraries?
It's just Swift with additional libraries.
It's not a clone Swift, no?
It's not a clone, but it is a fork. So it does have other features. We'll talk about it a bit more later on, but it has features at the language level and the compiler level that the main Swift doesn't have. So let's have a look. Can we have a look? Probably should have tested my internet before I did this. Come here. All right. Please hold. How about now? Hmm?
We could see that was you are almost
Hey, thank you. And then if I do this, are you going to behave yourself? Yes. Okay, thanks. All right, so first of all, this is Swift. This is Google Colab. Has anyone heard of this before? A little bit? If you haven't, have you heard of Jupyter Notebook before? Most people. So basically, this is Jupyter Notebook on Google's cloud compute background, and it is effectively a clone. What's interesting about this particular feature, sorry, I'm going to have to do this with most of my back towards you because I can't see it on both screens, but hopefully all I have to do is press Shift Enter, so we should be fine. Let's test one. Yeah, okay, cool. So this is Swift running in a browser that's running on Google's cloud somewhere. And as a backend, you can access Google's GPUs and also TPUs to do your model training, which is for free, to be clear, which is pretty cool. I mean, and there are some restrictions around it, but the hardware is not mucking around. There are NVIDIA T4 processors behind them, which is pretty serious. And there are some limits around how long you can stay connected for, and it might randomly kick you off. It might randomly kick me off when I'm doing this demo. We'll see how we go.
So usually Python notebooks run on Python.
That's right.
How do you set the language for this script?
So you can do it basically in Colab. If you go up to the runtime, you should be able to choose, where are we? Change runtime type. And there's a link from the Swift for TensorFlow repo that will let you select this in particular. So normally you just have Python 3 and Python 2. But through some magic, if you open it from their repo, you have Swift as an option as well. So even with nothing else, it's kind of fun to play around with this just in pure Swift. And they do have some magic about being able to import libraries from GitHub and install them in your Jupyter Notebook and things like that. Like it's pretty interesting. So this next section is mostly for the ML crowd about how Swift is different to Python, so we can sort of mostly skip over that. But one thing that I think you guys will be interested in is as part of the Swift for TensorFlow project, what they've done is produce a pretty tight Python integration with Swift, because a huge amount of the data science tooling is in Python, and they've got all these different libraries like matplotlib and pandas that mean it's kind of hard to do work without them. And those libraries don't really exist in Swift, right? So what we've done here, if I can scroll down a little bit, here's some pseudo-hybrid, actually, let me just, because in case you don't believe me, some hybrid Swift Python code that when I run, it's going to import the Python library pandas and then create a pandas data frame and use Python matplotlib to plot it in a Jupyter Notebook with a Swift backend. Got it?
It's just a front-end UI part. Swift is like acts as a front-end UI.
Well, we can get to that a little bit later. But basically, this is just pointing out that like the integration with Python is reasonably good. And if you want to start doing stuff, if you're a Python dev that's looking at playing with this, and you just want to load some data or you just want to plot a graph, then you can do it this way.
What application are you using? It doesn't look like that, but not like.
The question I'm going to come later. We use the question at the end.
Yeah, we can do questions at the end as well. I mean, this application overall is called Colab. And it's just it's a free web thing you can get from Google. But here's some of the interesting parts. This is the module TensorFlow. So we can just import TensorFlow. And this is a Swift library now. From here on, well, that's not quite true. From here on, we're mostly pure Swift. And so this is what the bindings look like. Now, we're going to create a tensor. And a tensor, if you've never used TensorFlow, is just TensorFlow language for a very large array of arrays. It's like a big matrix, right? It could be multi-dimensional. And as you can see, there's a few different ways of initializing them, either just from a Swift array, or you can use Swift to create an array that you want and then turn that into a tensor. It's got its own initializations, because that happens a lot in machine learning. You need to sort of generate a giant matrix full of various numbers. And it works, right? So you've got here, the types are all Swift types. So these tensor floats, and there's all different kinds of tensors as well that are included with the Swift for TensorFlow library. All your sort of standard tensor operations work. So you can index into them. You can broadcast over them. You can find out their standard deviation and things like that. And then you can sort of start using some of the Swift's good features, like type aliases, if you're sick of typing TensorFloat all the time. And you can extend things. And if you look at the library, I don't want to dig into it too much and show you, but if you look at the library, a lot of the way that they've done it is fairly Swifty. And they're using extensions, they're using things like this that make your code eventually quite expressive, right? Coming as a Python programmer, moving into Swift. I found it a little bit kind of confronting at first because you've got to declare all your variables and there's all these awful error messages and all this anal stuff about types and it's a real pain in the ass until it's not, and then it's amazing, and then now I'm like a total convert, right? So once you get past that point, it becomes very expressive to do relatively interesting things in a very little amount of code. Also in Swift with TensorFlow are all the TensorFlow neural network layer types, right? So you can create your own convnets and your own RNNs and do all that sort of stuff as well. I don't want to go into that now because I don't want to turn this into like a machine learning tutorial, but everything that you can do in TensorFlow, you can do in Swift with TensorFlow. That's the raw thing. 3/4 of it has nice Swift bindings. The rest you can access through like a raw API. So let's see if we can find my presentation again. Of course I can't. Right. No, doesn't like me. Because why would it? Sexy. So the big question to me is, now that it's possible, why on earth would they bother? Right? Like, TensorFlow is kind of already the 800-pound gorilla in the room. Everyone's pretty happy using Python. People love Python. It's got a massive ecosystem already of users and tooling. Why on earth would they start again? And why do I care about it, and why do you care about it? And there's a lot of different whys, but we'll start with the first one. And the answer has to do with the edge of the world and turtles, right? So if you are a Python developer doing machine learning stuff and you're doing machine learning research, you're sort of here, right? Like you're right at the edge of the world. Because a lot of what you do is pushing the boundaries of what your stack is capable of. Python itself has some limits, right? It's relatively slow. It has the global interpreter lock that makes multitasking stuff pretty difficult. But there's also the machine learning stack in Python really is turtles all the way down, right? It doesn't take you very long before you're dealing with some code that's generating code that's generating code, and you're in the middle of developing some new layer type and you get an exception that's being generated at runtime by CUDA, and you're up here in your Python code going, what the hell's going on? And you've got no tooling to really reach into that problem and work out what's going on, right? And if you're trying to create a new layer type that's not supported by PyTorch, for example, or by TensorFlow for that matter, then you're really hamstrung as a researcher. Because if you know Python, really PyTorch is written in C++. And so if you don't know C++ and you don't know CUDA, then you can't go in and like write a new thing. So the idea behind this is to really integrate the like high-level user code all the way down to the compiled code. So I don't want to go into this too much. This is the second scariest slide. But there is a lot of stuff happening at Google as well under the hood about the compiler architecture around machine learning. So most of you probably are aware of the new neural engine chips in phones, right, in the iPhones. Most of you also have heard of the Google Edge processor units, the Coral units and things like that, and there's NVIDIA Jetson things coming out. And there's all these special purpose chips that are designed to accelerate machine learning things. And the architecture to compile the code that you write into the various different heterogeneous architectures is pretty complicated, and it's not very good right now. So they're changing that a lot. So Chris Latner, before he wrote Swift, wrote LLVM, the compiler infrastructure. So he knows compilers, right? And his team at Google also knows compilers, having worked with them a little bit. They're very, very, very smart people. And they're not just smart, but they have a good sense of how to do things the right way, right? So they're sort of looked at the current problem and they're re-engineering all the back end. And Swift's language architecture, unlike Python's, is capable of taking advantage of that, right? I sort of won't go into it much more than that, but in a year's time, when this infrastructure is good and the Swift for TensorFlow project has moved along a little bit, you'll be able to basically have performant first-class code in a nice high-level API that you'll be able to invent new stuff in that will run on the processes, which, if any of you have done any kind of machine learning research, that should sound pretty exciting. Sorry if it doesn't. Trust me, I'm excited. This is the scariest slide because it's got equations on it, right? What machine learning is, broadly, is a lot of matrix multiplication. And what you sort of it's like that hot and cold game that you play with kids, right? It's like you tell the computer that you want to be over here, and it tries moving closer, and you say, you're getting warm, and then, oh no, you're getting cold, you're getting cold, you're getting cold, right? And so you sort of, every time it does a bunch of matrix calculations, you look at it, at the result, and you say, how close are you to where you want to be? And you say, you're really far away, or you're really close. And the way that and then you go back and redo all the numbers in the matrices and try again. So the way that you do that is by taking the derivative of the function. Don't worry if you don't even know what that means, but it means that you have to do a bit of calculus, right, to push it all the way back, and that will tell the algorithm what new numbers to put in the matrix. And at the moment, libraries like TensorFlow and PyTorch have made that pretty easy, but actually doing it, and especially if you have a custom function at any point, working out the derivative of that and applying it into the chain of operations is very difficult. And so there's this kind of concept known as differentiable programming, which is kind of an abstraction of once deep learning is over and it's not cool anymore and no one says deep learning, basically what we're left with is just writing code that writes itself. And the idea is that you should be able to basically, in your normal program, say, oh yeah, and by the way, here's a bunch of data, you work out how to decide between them, and then once you've done that, we can carry on, right? So you're no longer in some abstract machine learning space, you're just in a world where you are doing differentiable programming as a first order language task, if that makes sense. And that's kind of, this is my alien technology slide, right? Like this is kind of some future stuff that we're pushing at. It doesn't really exist, but it's going to need to exist. Once all this is over, and TensorFlow is, as it currently stands, is dead, and PyTorch is over, and everyone's sick of doing deep learning because everyone's sick of hearing deep learning talks. I don't blame you. All that's going to be left is people are going to want to do differentiable programming, and Swift at the moment is the only language that has now, and it's one of the only languages that's possible to include that function as, like in a first-class way, because of the way that its compiler architecture and its language architecture are designed. So it's pretty cool. Like that's why they're doing it, and that's why they chose Swift. That team has a very good and concrete explanation about why they chose Swift in particular for the job. That explains it better than I'm doing it now. But it's not just good now, but it's, I think, really cool about what it enables in the future. So that's all very exciting, but why wouldn't you use it today if you're a machine learning person? Basically, it doesn't work very well. Minor detail, right? It's very, very, very early days. I mean, that's not true. It does work, right? Like the differentiable stuff works, the layers work. You can, and I have trained models in it. But for example, they're just developing it so fast and it's so alpha that the actual demo that I had planned for this evening, I updated to the latest nightly build and it doesn't work anymore. So that sort of thing is happening a lot at the moment, and which is good because it means that they're like working on it, right? But it means that if you don't try and re-implement your production system in Swift for TensorFlow yet, like wait a year. But it's cool. This is how many issues are open last week or 2 weeks ago. This is their rate of closing and resolving. Good on them for doing it all in the open. This is not very many, and they're still working hard, but people are like starting to use it, and it's starting to pick up momentum, both in terms of users and in terms of dev team, right? Another reason that you don't want to use it, as we sort of saw before, all of these awesome libraries that we know and love don't exist in Swift. And this is kind of indicative of the broader problem of using Swift as a general purpose language, right? Like I'm a recent convert to Swift. I'm totally in love with it. I think it's awesome. But you have to write everything from scratch, right? And the Swift, I mean, what we saw last week at DubDub with the new integration of Swift packages in Xcode might improve this, but the broader Swift package ecosystem and also the cross-platform Swift ecosystem is not very well developed, which can be a problem. And specifically in machine learning world, people use Windows. That's a thing that still happens, believe it or not. And that is kind of questionable for Swift in general and Swift for TensorFlow in particular. So support for Windows is dubious. So those are the major... So what have we done so far? We've done who am I and who are you. We've done what it is. You've seen what it is. We've done why we're doing it. Let's see where it fits into the overall picture, because that's one of the things that I found confusing when I first learned about it, right? So I don't know how many of you will be familiar with how many of these technologies, but this is Tom's very, very broad map of the machine learning landscape at the moment, right? You've got the core ML stuff over there, TensorFlow and PyTorch. Extremely roughly, you've got things to make models along the top and things that can run the models in the middle and things to run the models on down the bottom. So where does the bird go? It is a bit confused. I would put it about there. So it's one of the appealing things about Swift that I'm continually more excited about is because it is so general purpose, like it's so performant at a systems level, but also so high level to use and make application architectures with. In theory, it's one of the few languages that you could do really low-level programming and also then kind of deploy that across some production system and have that all done in one app, right? The potential is very cool. I know that the Google people see this that way as well, and you know, I have no insider information here, but reading between the lines, if they have a team doing this, I'm betting that like Google sees this as a way forward, right? Like it's more broadly for Swift. It's a pretty big player coming into the Swift ecosystem in a fairly serious way. So like that's of interest more broadly. Machine learning-wise, specifically, you can use it for training, and then the models that you built, you could write the same application in Swift and deploy it. But it's got, particularly of interest to this crowd, it's got nothing to do with Apple, right, at all. So Apple has their own stuff, the Core ML stuff, which is very good. But the TensorFlow world does not interact with it very much. You can, in theory, convert a TensorFlow model into a Core ML model and run it that way. That, I don't know, up until last week anyway, didn't work as well as it should have. I haven't tried it since. Maybe it's awesome now. But just because it's Swift doesn't mean it's going to work in iOS, right, is the short answer. And I think that's a little bit, well, it's a bit of a shame, but it's also worth pointing out. So what about you? If you're all super excited, like I am, what can you do? You can do heaps. Heaps and heaps and heaps and heaps, because there's heaps and heaps and heaps to be done, right? It's all being done in the open. It's all open source. There are lots of bugs. The team, having spoken to them personally, they're very, very welcoming, and they're going out of their way to try and engage with the community to get people to help, for obvious reasons, but also because they're just nice. They have specifically a list of starter bugs, half of which are like documentation bugs, and if you want to get involved, even if, or especially if you're a beginner programmer or a beginner Swift programmer or just like someone who's half interested, you can do, contribute to, they say specifically what kind of tests they need, what kind of documentation they need help with, all that sort of stuff. And they're good about merging pull requests and that kind of thing. For those of you who are more Swifty, this is my Tower of Babel slide. This is my opinion, they sort of need help with the language idiomatic factor, right? They're all Google engineers, they're used to writing really hardcore Java and C++ applications. Swift's nice, lightweight, functional features. They've done a great job of implementing them as they are, but like the API design and stuff like that, they need help from the Swift community to make it as Swifty as possible, right? Especially because it's going back, and obviously this is under review because they're going through the Swift community contribution process. But if you are interested and you know Swift, then they need you. They're also hiring, for the record. And if you're interested in building stuff, then this is a very, I guess, in a way, this is the positive spin, right? But there's a very rare opportunity for you to get in on the ground level and build something here, because none of it exists. The whole field is completely wide open. And speaking from experience, like if you're the first person to write a library that is even this useful, it will immediately become the de facto thing that is used, right? So whether that's appealing or not is up to you. It's not always a good thing, but if that's something that appeals to you for whatever reason, then this is an excellent chance to do it, whether it's just because you hate it when it's done badly, or whether it's because you really want to have your name all over everything, or you want a good resume point, or whatever it is. This is a good chance to kind of become, like I'm pretty convinced Chris Latner and Jeremy Howard, what they've done in the past has succeeded almost universally. So, if you bet on the people, not on the thing, then these are good people to bet on. So I'm pretty convinced that this project is going to have legs. And if you want to be the core library of, the matplotlib of Swift in 2 years' time, then now's your chance. So, conscious of time, I think that's pretty much all I wanted to touch. We covered most of the things. These are the main points. It solves real problems right now. It's got real momentum. It's not Core ML, which is a bit of a bummer, but its Swift overall is about to get a whole lot cooler with everything. And I hope that gives you some understanding of what Swift for TensorFlow is and where it fits and what you can and can't do with it. And I'm going to be hanging around later if you have any other questions. Any questions now?
Done silence. We use the mic for questions so that it's recorded as well.
I was just going to ask, you put a cross through a bunch of Python libraries and said they no longer exist. Are the Swift to Python bindings really not acceptable, or is it just that there's a mismatch between the languages?
At the moment, it's just a mismatch between languages. Overall, the Python integration is very good, but it's a bit like I've found it kind of like walking along a frozen lake. Like everything's totally awesome until you fall through the ice and die, right? Like it's terrific, but then you hit some edge case. I mean, this is probably half a function of the fact that it's new and half a function of the fact that, in theory, I mean, again, just my opinion, the worst case scenario would be that everyone gets trapped in some half-life limbo forever of relying on Python for Swift for TensorFlow, right? So you kind of want some incentive to build the actual tooling in actual Swift. So that all of your Swift for TensorFlow projects don't secretly depend on some ancient matplotlib version, right? Like that's kind of a horror story. So I don't know if that's what they're thinking of when they're addressing their prioritization, but overall it's not quite true to cross it out. Like you can, I mean, you saw me do it, right? Like that wasn't a lie. You can use those libraries from Swift, but I wouldn't want to rely on them.
So we have IBM Kitura framework
Yeah.
as well. So where does that fit in between the stack?
Fit into this?
Yeah.
It's probably parallel, if anything. One thing that I want to do more as a sort of interest project is try and make effectively one project that uses Swift and trains a model in Swift for TensorFlow and then makes a web app in Kitura and serves the model, like predictions based on the model. So you can sort of prove that whole training and production thing in one project. In theory, that should be possible.
Yeah, and we have like, so TensorFlow is more of ML.
Yes?
But we need to have more models like data analysis.
Yes, that's right.
So where does those kind of libraries going to fit in?
Well, I mean, there's a Google Summer of Code project happening at the moment, and a lot of the projects in that batch, what do they call it? Batch, are all about building out the rest of the kind of broader data science, well, data analytics tooling, so more traditional machine learning algorithms and more stats libraries and things like that. But in the meantime, you can use the Python ones.
Anyone else? No. Thanks, Tom.
Cool.